So today's session, we will be starting with a topic called as method overloading. Okay, so as you all know, overloading is a way of implementing my polymorphism. So overloading is actually a way of implementing my concept of polymorphism. And remember, it represents my static polymorphism type. So I hope you remember during our starting sessions, I told you polymorphism is of two types. One is my static and one is my dynamic. So this overloading concepts is a way of implementing my static polymorphism. Right. Now, what exactly is this overloading? Okay, and how to go about it? So this overloading concepts can be done with two things. Can be achieved with your methods, that is nothing but our functions, and also with something called as constructors. So this overloading concepts can be used in two scenarios or two different situations. One is with methods, that is with functions, and the other one is overloading can also be done with my constructors. So what is a constructor, how to go about it, we will be seeing it in the next upcoming session. Okay, so first let us try to understand this overloading. So let us take an example. Okay, in a program, let us say in a program, I want to add two numbers. Okay, I want to write a program to add two numbers. So you know how to create a function. So let us say I'm going to be creating a function in this manner. So public, let me take it as void, no problem. Void addition. Okay, or else let us be more specific. I'm saying int. So now here, what I want to do is I want to, okay, here this addition function, I want to add two integer numbers. Addition of two integer numbers. Okay, that is a logic I am going to write inside this program. Now, in my program, I want to add two double numbers also. So that task is also addition. So why should I give a different name for that function? You understand my point? So in my program, I want to create two different functions. So what is the task in my program? I want to create two methods. Both the methods are going to perform the same action. So both the methods are going to perform the same action. And what is that action? Addition. But what is the difference here? The first method, the first method is going to add two integer numbers. The second method is going to add two double numbers. But the operation that it is going to perform are both addition. So my question is, why should I give different names for this method when the performance what it is going to do is same? See, generally we have a naming rule. We like to name the function basically to what it is actually doing. For example, that is why in the previous examples, I gave the function name as get data, show data. That is the work of the function. That is always we should be giving a meaningful name. That is the major thing we have to follow. So it is not a mandatory rule, but it is one of the best practices. Whenever you're going to be creating a function, it is always best practice to give a meaningful name for my function. And since here my operation is going to be same, I want to give the same name for the function. But the code is going to be different. But the code, what it is going to do is going to be different. Like this, I want to create. But now, please remember, my compiler will not allow us to do this. If I try to do this, it is going to throw me an error. See what it says. Method addition is already defined in the class test. So only one method, okay, only one method can be created of that particular name. That is, method name must always be unique. Method name must always be unique. If I write the code like this, it is going to end up throwing errors for me. So how can I solve this? Okay, say for example, next one, I want to add two double numbers or two float numbers. For that also, I want to give the name as addition only, because that is also going to do the same process. So why should I give a different name? So what is the point here? What is the main thing? Function name or method name must always be unique. Generally, in a class, the rule we follow is the method name must be unique. But when I am going to be performing the same operations, I don't want to give different names. I want to give the same name only. So how can I solve this situation? So for this only, we use the concept of method overloading. See, overloading means creating multiple methods with the same name. So this is what you mean by overloading. Creating multiple methods with the same name. So in a class, I can have even 5 functions, 10 functions, 20 functions with the same name. But something must be different. What should be different? That is nothing but the method signature. So I should show the difference. Why I should show this difference? You understand? Why to show the difference? Why is that I should show the difference? If there is no difference, how will you know which method to call? So when there is no difference, how will my compiler know? Which function or which method to call for my function calling? So this is why we have to show the difference. So please understand what I'm coming to say. A function, a class is going to have multiple functions with the same name, but I have to show the difference in some point. That difference is shown in something called as method signature. Now, why to show this difference? Because if I don't show this difference, the compiler will not know which function I am calling, because every function is going to be same. Every function is going to look same. So which function am I calling? What code to get executed? That my compiler will not understand. That is why showing the difference is very, very important. Okay, now what is this method signature? So what is this method signature? I'm saying that you have to show the difference in the method signature. So what is this method signature? So the method signature comprises of three parts. The method signature actually has three parts. So what are the three parts of a method signature? The three parts are, first one is difference in parameters. Difference in number of parameters. Second thing is the difference in data type of the parameters. And the third part is difference in sequence of parameters. Now, let us try to understand what are these. Let us try to understand what are these. That is, whenever I am creating a function with the same name, I should show some difference in any of these three. The difference can be there in any of these three categories. One is based on the number of parameters, or the difference can be based on the data type of the parameters, or the difference can be based on the sequence of parameters. Now, let us try to understand this with an example. Okay, so here, as I said, I am going to be creating addition methods only. So let us say public. Okay, I am saying void add. The function name I'm keeping as add. This add function takes no parameters at all. Zero parameters. Nothing. Okay, next add function I'm creating. I am saying public void add int a comma int b. So this is a add function. See, this is also add, this is also add. But what is the difference between these two functions? Here it has zero parameters, whereas here I am having two parameters. So the difference has to be shown in any one of these three. Now, let us write another add function. So I am saying again public void add. But this time, see what I'm saying? Double A, comma, double B. So the difference between these two functions, this is also two parameters, this is also two parameters, but data type is different. This is integer, this is a double. So as I said, data type of the parameter also can be different. So first one, here I'm showing the difference between number of parameters, and here I am showing a difference between the data type of the parameters. Now let us take another function. So in this function, I'm going to show you the difference like this. This is also two parameters, but here, what are the values? I am having one string and one integer. Two parameters, but different data types. Okay, now let us create one more add. Okay, let us create one more add function. So there you go. Public void add. Here, see what I'm saying. Now, see the difference between these two. Look at the difference between these two functions. This also takes two parameter. This also takes two parameter. Here also one string, one int. Here also one string, one int. But sequence. How is it given? Here first string comes followed by an integer. But here first integer comes followed by a string. So this is how I will be showing you the difference. So the difference can be shown either in number of parameters or the data type of the parameters or in the sequence of parameters. But all my function name is going to be same. Okay, all the functions are going to do the same work. So I'm going to be giving the same name for them. Right, so now let us write the code inside. Right, so then let us create the variables. I want to store it in A, and then let me give you for the B, and then of course I have to find the sum. And there you go. So my first add function is ready. And now coming to my second add function. So here, what I'm going to be doing. See, here I'm just going to say a plus b. Why? Because here the values are going to be passed when I'm going to call the function. So that is why I'm not creating any scanner class inside and asking for the values. Now coming here again. Right, now coming to this one. I'm just going to say I am learning lang plus version plus var. Okay, so here we are just going to do the simple operation of concatenation. Right, now for this add function, right, so what will happen when I use the plus operator on strings? It will do the work of concatenation, or rather we call it as joining. So it is just going to join the values of my strings. Now here is what is going to happen to this value also. I'm just creating a string by concatenating all these values. Okay, so here I'm going to say something similar. So what is that I'm going to do is I'm saying string str is equal to, there you go. Okay, I have just created the string again with adding these values. Now we are just going to print it out. Right, so now all my functions are ready. So how many functions I'm having? 5 functions. All the function name is same. Now Remember, all of these are instance function. That is, they are belonging to the object. So the first thing what I have to do, create an object of the class. There you go. Object created. Now I have to call the function. See, when I give t dot, look what all it shows. Look at the different versions it is showing me. Now, first thing I'm giving this, I'm calling this function. So here I have to provide the values. So I am saying when I am going to be calling the function like this, what will happen? I am saying t dot add 5 comma html. Now you already know whenever you pass the arguments, what will happen? It will go and it will get assigned to the parameter. So now, why do I say this is a static polymorphism? First, please understand polymorphism means what? One object exhibiting different behaviors. So here I am having different behaviors of the add function. Okay, each and every add function is different and it is all different behaviors shown by this object t. Because using that t only I'm going to call the add function. So these are the different behaviors exhibited by the object. Okay, now why it is static? This is polymorphism. An object exhibiting different behaviors is polymorphism. Now why do I call it as a static polymorphism? Okay, I'm calling this static because when the program is going to be compiled, okay, so first when I run the program, what is the first step it is going to happen? It is going to compile my code. So it is going to do all the error checking. So if nothing is there, my program is going to get compiled into a dot class file, or rather I call it as a bytecode. Right. So during this compilation itself, all the mappings are done. Mapping in the sense for this function call, which function's code needs to be executed. That is decided at the time of program's compilation itself. That is why we call it as a static polymorphism. Remember another name, early binding. Another name for it, we call it as early binding because of this reason only. So also known as early binding. Okay, so early means what? At the time of compilation itself, everything is going to be linked. Everything is going to be mapped. Now, when I call the function like this, what will happen? Integer string, which is matching. This is matching. First value is an integer, second value is a string. So this function call matches this function signature. So for this call, this is going to get executed for me. Now, next time when I'm calling this, okay, next time when I'm calling this, I'm giving some value like this. Add of 45, comma 98. So here both are integer numbers. So it is going to go and invoke this method because this is the method which is again matching the function signature for me. Now, next time when I'm calling something like this Java and I'm saying 19. Okay, so this is first string value followed by an integer. See the difference between this function call and this function call. So accordingly, whichever function signature matches, it is going to be calling that method. Now I'm not giving any values at all. Remember my first add, which takes 0 parameters, is invoked here. Then I'm saying t dot add of, let us give some value. For this, the double function is going to be called. Now, when I run this, see what happens. Version 5 is the latest version of HTML programming language. Then it calls the another add function. Then it says I am learning Java version 19. Then enter the value. So how all my functions are getting executed one by one. So overloading is the concept where you will have the same function name, but the function definition will change. Function definition is going to be different for this. Right. Now, there is one more very, very important point that you have to remember when you are doing your overloading. Return type. Return type of a method is not part of overloading. So, guys, a very, very important point this is. So, what do you mean by return type of a method is not part of an overloading? Okay, say for example, I am creating one more function. But here, look what I'm saying. This is also add. This is also add. Now, what did I say the difference should be in? Either the number of parameters or data type of parameters or sequence of parameters. You should know that show the difference in at least any one of this. But here, is it any different? Number of parameters? No. This is also 2. This is also 2. Data type of the parameter? No. This is also intent. This is also intent. Sequence? No. There is no difference at all. But what is the difference here? Here this function return type is void. Here this function return type is int. Is this overloading? No. This is not overloading. When you see here, see what it says. Method addition is already defined. So that is what I said. Your function return type is not part of overloading. Say for example, if I give like this, it will end up throwing errors because it is an error. Return type is not part of our overloading. So just because return type is different, it does not mean overloading. So please remember this very carefully when you are writing your programs. Right. So these are the important things that you should be knowing with regards to our overloading concepts. So why overloading is for this. Whenever in a project, in a program, you are required to do the same task, but for different inputs, for multiple different inputs. Then instead of giving different names, because it's very difficult to remember all the names. How can I remember all the names? How many functions are there? So what else? So addition 1, addition 2, addition 3 like that? No, right? So that is why we are going to be giving the same function name but with different function signatures. Right. Now, let me add this example so that I can share you this notepad later. So other than this, you can create another functions also. It is not that in a class, if you're going to do overloading, all the functions name should be same. Not like that. Whichever functionality you want, you can keep it same. We can create other functions also. For example, I'm giving something like this. So I have created a function with the name MSG. So I'm calling this function first. So I'm saying P dot MSG. Now when I run this, see what happens. So this is a program explaining the overloading concept. So that is getting printed, followed by all the other things one by one. So that is what I said. It's not compulsory. Just because I'm having overloading does not mean that all the functions I'm creating for the class should have the same name. No rule like that. Whichever functions you feel is going to have the same functionality. So for remembering, for our convenience, we are going to be giving that same name for it. Right. So yes, there you go. Yes, done. So this is our concept of overloading. Right. So I told you today we are going to be dealing with two concepts. One is overloading. The other concept, the other topic what we are going to be discussing today is constructors. Is the topic of constructors. So now constructors are very, very crucial in your programs. Okay, so what is this constructor? Why do I require constructors? So the first thing you have to understand is why. Why do I need a constructor? So far, I have been creating my program. I never used the concept of constructor. So why now? Why is this necessary? Okay, so now for that, let us try to understand that with a small example. Let us say I'm going to create a variable like this. So of course, it is an instance variables. It's going to be an instance variable. So let us say string name and email ID. So these are the two instance variables what I'm going to be having. Now, how to give the value for this instance variable? How can I, what are the different ways I have to give a value for an instance variable? Remember, instance variable. So compulsory, it belongs to the object. So for me to access these variables, I need an object. So that is mandatory. That is not going to change. So what I can do, create an object, then I can say t dot name is equal to t dot email is equal to. So that is one way of giving. But that again becomes static inputs. That is, I am assigning the values, but I want to take dynamic inputs. So what I'm going to do, I'm going to create a function. So I am saying public void get info. That is the name of my function. So inside this function, I am creating an object of the scanner class. And then I'm going to be getting this value. Right. And then for the email ID. So name is there, email ID is there. Done. So now, when I execute this program, will it work? And let us create the other function also. Okay, so where I'm saying done. So just I have created the functions, I have created the object. So when I run this, will it work? No. I have to call the function. So in order to initialize the value, for these variables, I have to call the function. Only when I call the function, the code inside that is going to get executed. So I have to say t dot get info. Then I have to say t dot show info. Like this, when I give only, this code is going to get executed. And this function I'm calling with object with the t. So t dot name is equal to, it is going to get some value. T dot email equals to, it is going to get some value and store it. So now when I run this, yes. So enter the name. Yes. Enter the mail ID. So now it is taking the values. So remember, initializing a value for an object variable, that is initializing the value for an instant variable, happens in two steps. So when we want to initialize, when we want to give a value for the instance variable, how are we going to be doing it? So step number one, we have to create the object. Okay, and then you have to either call the function, so call the method and initialize the value, or what you can do, using the object, initialize the value. So we have to follow either one of this. So what you are doing, first step is create the object. After creating the object, call the method with the object you have created, or using that object, initialize the value. Say for example, let me take this as T1. For T1, I am giving dynamic inputs. Let us say I'm creating another object. So for T2, I'm going to be giving static inputs. Static inputs means what? Directly initialize the value. That is, I'm going to say T1 dot, sorry, T2 dot name is equal to T2 dot email ID is equal to. So either I can give the value like this, or I can give the value like this. So these are the two different ways in which I'm going to be doing it. And of course, I need to print the values. So here I go for printing. So here what I'm going to say, T2 dot. Here also T2 dot. Right, now let us run this code. So for the first one, it is going to ask for dynamic inputs. And for the second one, it is going to take static inputs. Yeah. First value, second value, but program is working. So whenever you create an instance variable, you are going to be giving the value for the instance variable in any one of these two methods. So dynamic inputs using function, using methods, Or you can give static inputs like this, or you can also give like this. Another way of doing, you can also give like this. Let us create T3. This is another way of giving dynamic inputs. But here, what is the problem? If you are using this method, we have to keep on repeating the code again and again. That is the problem. Data repetition will happen. Three dot. And then I can print the values. I can print the values. So I can give any of these three methods. This is what we have seen so far in all our previous programs. I'm just consolidating everything and giving you. We saw about instance variable. We saw about how to create your methods, inputs, everything together. So these are the three different ways in which I can give the values for my instance variables. But all of this, have you noticed? All of this involves two steps. All of this is a two-step process. You can do any of this only after creating the variable. Before that, you cannot do anything. First, you have to create a variable. Then, using that variable, you have to call, first you have to create the object. Using that, you have to call the function. First, you have to create the object. Using that, you have to initialize the values. Create the object. Again, do this. Any method it is. First, object needs to be created and then only the value is got. So, always a two-step process. Right. So, how I can minimize it? How can I minimize it? That is the role of your constructors. So this is what happens without constructors. Without constructors, whenever you are having instance variable, these are the different ways in which you give the values. Right. So now, when I use a constructor, what is the advantage? When I use a constructor, what is the advantage? Constructors. Okay, constructors are a way to initialize the values. At the time of instantiation, that is object creation. So what exactly is a constructor? A constructor is a way to initialize my instance variables with values at the time of instantiation. That is, when you are going to create the object, at that time itself give the values for your variables. One step process. Make it into a single step process. Making the entire task into a single step process. That is the role of my constructor. So what is a constructor? A constructor is a way of initializing my instance variable with values at the time of instantiation, or at that time. Instance means object. Instantiation means object creation. So this is the role of my constructors. Now, there are some special points or key points you have to know about your constructors. So, what are those key points? So, point number one, constructor is always, okay, your constructor name. So first point is constructor is a special method. Constructor is a special method. You know what is a method? We have discussed so much about methods. So a constructor is a special method. Okay, now how to create a constructor? What is the syntax? What is the syntax? So you just have to remember one more point before going into the syntax, that is the name of the constructor. The name given to an constructor is always same as that of the class name. Please remember that is name of the constructor and name of your class must always be same. So name of the constructor is always same as that of the class name. That is the reason I'm calling it as a special method. Normally for a function, you give the names. You can give any name as you want. But when it comes to constructor, it is a special method. Why I'm calling it as a special? For two reasons. Reason number one is constructor is always going to be of the same name as that of my class name. That is reason number one. Okay, reason number two. Reason number two is there is no return type for a constructor. So constructors do not have any return type. Remember, whenever you're creating a function, return type is mandatory. But when you're creating a constructor, you will have zero return type. No return type at all. Not even void. See, whenever you're creating a function, if the function has no return value, you will write void. But for a constructor, you will not even use the void keyword. No return type at all. That is why we call the constructor as a special method. One is because of the name. Second one is because of the return type. So now coming to the point, how can I create my constructors? So my constructor is going to be having the syntax something like this. Public class name. Then if you want, you can give parameters. If you don't want, you don't have to give. That's your choice. Followed by some statements. There you go. This is how your constructor is going to be looking like. So constructor is a special method which is going to have the same name as that of my class name, which is not going to be returning any values. Okay, so these are some of the very important points you have to remember about your constructors. Okay, and the fifth point is constructor is always access specifier for a constructor is always going to be public. You can create private, but if you create as private, there will be some issues, which we will discuss later. But as of now, just remember, access specifier for a constructor is always going to be public for me. Private constructor, some situations you may create, but it is not advisable. So always going to be public for us. Right. Now, can be overloaded. Can be overloaded. Constructors also, because I said it is a special method. And overloading, we just discussed what is overloading. So remember, in constructors also, you can do the concept of overloading. Okay, now another important point is overriding. Overriding is not possible. Overloading is possible. Overriding is not possible. So overloading, static polymorphism. Overriding, dynamic polymorphism. So dynamic polymorphism with constructors you can't do. But static polymorphism, yes, it supports. It supports. Right. So these are some of the rules you have to remember when we are dealing with the concept of our constructors. Right. Now, talking to you about the different types of constructors. Please remember, constructors are categorized into three types. Types of constructors, you have three types. So what are the three types of constructors? Point number one, default constructor. You have something called as a default constructor. Then I have something called as a non-parameterized constructor. Non-parameterized constructor. And then I have parameterized constructor. Then of course I have parameterized constructor. So these are the three types of my constructors. Now in this, the first one is created by my compiler. The remaining two are created by the programmer. So please remember, default constructor is created by my compiler. And the parameterized and the non-parameterized constructor is created by the programmer. Now, when does the compiler create my constructor? So when your program, when the class or when your does not have any constructor of its own, then the compiler will add a empty non-parameterized constructor. There you go. So when is your compiler going to add the constructor is when a class do not have any constructor. You're creating a class. You have not added any explicit constructor. That is, you have not created any constructor. Okay, but still you're creating an object for that class. Now remember, what is the syntax for creating an object? You are going to say creation of object. We follow this, right? Class name. Then we give the object name equals to new. We repeat the class name. We repeat this class name of. We give like this. Now this portion is nothing but my constructor. But I have not given any constructor. That is, I have not written any code for the constructor. So when I'm creating the object, my program should not throw any errors. For that reason only, your compiler will add an empty non-parameterized constructor to your program. So please remember, whenever you are creating a class and you have not created any constructor inside the class, then my compiler will add a constructor like this. So it will say public class name like this. Non-parameterized, that is no parameters will be there. And the empty constructor, no code also. Nothing will be present inside. It is just that so that this line is not going to generate any error for us. That's all. So this is how your default constructor is going to be looking like. And this is done automatically by my compiler. So please remember, you are not creating the default constructor, but rather your compiler is doing that. For example, take this program what we just did. Did we create any constructor here? No. Why I'm sure? Because constructor name and class name is going to be same. Have I created any method called as test here? No. So no constructor for this class. But still, I'm creating objects. See, I have created 3 objects for this class. But still, there is no error in the program. It is working smoothly because my compiler, when I'm executing this program, has added a default constructor for me, so that when I am creating the objects, it is not going to be throwing any errors for us. Right, so that is my default constructor. Then, of course, I have my non-parameterized constructors. So, non-parameterized mean constructors without any parameters. That's it. Constructors without any parameters. Now, we have already discussed about what is a method, what is a parameter and all. So, I'm not going to be going into that again. So, whenever you're going to create a constructor without any parameters, it is called as non-parameterized constructor. So, now when you're going to create a constructor with parameters, it is a parameterized constructor with parameters. That is what you call as a parameterized constructor. Right. So these are the 3 types of the constructors I'm having. Now, there is one more very important difference that you should be knowing. Normally, when I create a method, I have to call the method. Unless and until I call the method, the code inside the method is never going to get executed. But that is not the case with my constructors. That is not the case with my constructors. So what is the another most important point about a constructor is constructors are not called explicitly. You don't have to call a constructor. A constructor is automatically called when the object is created. So what is the next important point for a constructor is constructors are automatically called, or what we call, technically we call it as invoked, when the object of the class is created. So there is no need to explicitly call a constructor. So that is another advantage that my that my constructors offer me. Now, let us try to understand all of this with an example. Rather than talking, let us try to understand all of this with an example. Right, let us go to this class. Let me remove all this. I'm going to add my main method. Then, let us create a constructor. Now, what did I say a constructor is? Same name as that of the class name. Access specifier is always going to be public. No return type. Okay, no return type. So, public test. And I said it's a special method. So, parenthesis. Method is always represented using the parenthesis. So, parenthesis is compulsory. Done. My constructor is ready now. This is my constructor. Okay, so I told you, let us take an example. Okay, okay. Inside this, I'm writing this code. Constructor invoke. That's all. Nothing else. Now, let us create an object of this class. So, class name is my test. So, T1 is equal to new test of. Now, when I run this, remember this is also a method, but I'm not calling this. I'm simply running this. See what happens. Whatever I have written inside the constructor is automatically called for us. So that is what my constructor is automatically invoked. What did I say? It is automatically invoked at the time of object creation. So when I am creating the object, this is my constructor calling. This part is my constructor calling. So whatever code I have written inside will be automatically executed whenever I am creating an object. And no matter how many objects I create, that many times constructor is going to be executed. Please check here. T2, T3, T4, T5. I'm creating 5 objects for this class. I'm creating 5 different objects for this class. Now when I run this, see what happens. How many times the objects are created? 5 objects are created. How many times my constructor is called? 5 times. So each and every object, when I'm creating, it will call my constructor. So automatically, whatever value you're giving inside the constructor will get initialized also. If I'm having some instance variables, let us say I have instance variable. So I have an instance variable and I'm going to give this as string name. This is my variable. So inside the constructor, inside of my constructor. Okay, first let me share you this code and then I'll write the next part of it. So for every object, for every object created for the class, the constructor is automatically invoked. Now, one more example as I was making the changes. Let me take all this. Okay, here. So you can add how much ever variable you want. I am just giving only one instance variable. So you can keep a whole lot of variables also. So inside this, so scanner class object done. Then I'm saying I'm asking the user to enter the name and whatever name they are going to give, I'm going to store it inside this variable name. Next line of right, done. Then I have one particular function, one normal function. So public void display name. There you go. So this is a constructor. This is a normal instance method. And this, of course, is my main method. This is my main method. Done. So here I'm creating objects. So creating the object of the class. So what is going to happen? What did I just say? Every time when you're creating an object, the constructor is automatically called for me. So whatever you're writing inside the constructor is going to get executed. Okay, automatically called. But now this is a normal function. This is not a constructor. This is a normal function. So you only have to call this function. So you have to call the function. Then only the code within that is going to get executed. So say t1 dot display name, t2 dot display name. So you have to call this methods. Now when I run this program, see what happens. Always the program's execution is going to start from the main function. In the main function, first it is creating object called t1. So for t1, it is calling the constructor. So the control will go inside my constructor. So whatever I have given here is going to get executed. See, that is why it is asking me enter the name. Done. Now see, again it is asking enter the name. Why? Because now this is over. This is over. So it will come back to this. This line is completed. So go here, create the second object. Again, constructor is called. So again, it will go back. Whatever code is there inside, it is going to once again execute it. So that is why it is asking me for the name again. So I am giving the see what it says. Now my display name function is called. So it is printing all the name values. So this is how my constructors are working. Remember, what is I say? What did I say a constructor is? Constructors are used to initialize my instance variable with a value at the time of instantiation or at the time of object creation. So when I am going to be creating this object itself, the value for this variable is assigned. Now you may ask, ma'am, here I'm saying only name. So how will it say whether it belongs to the first object or the second object? So that is because which object is getting created here? T1. So it is calling the constructor for on behalf of T1. So this is going to be T1 dot name. Next time when it is creating an object, the object name is what? T2. So it is calling the constructor on behalf of T2. So it is going to take it as T2 dot name. So based on using which object you're creating, what is the object name you're creating? For that object's instance variable is going to get initialized. Remember, I already told you, instance variable means what? For every object, it will have its own copy of the variable, individual data. That is my instance variable concept, right? So that is what is going to happen here. And remember, this is a non-parameterized constructor. That is no parameters. See, the constructor is not taking any parameters at all. So it is a non-parameterized constructor. So this is a small example for our program. So an example of a non-parameterized constructor, how it is going to be working. Now, let us take a parameterized constructor. I'm saying I have a parameterized constructor. So how can I give the values for that? Okay. Now, so no need of any scanner class, nothing here, because the constructor is going to have a parameter. So whatever is the value of this parameter, that value I want to assign to this name. So what I'm going to say, name is equal to NA. That's it. Name is equal to NA. Now what will happen? Now what will happen? When I am going to call the function, sorry, when I'm going to create the object, at that time, I have to pass the value for this. Why? This is a parameterized constructor. A constructor having a parameter. So when I am creating the object for the class, I have to pass the value for this parameter. Please remember that whenever you are having a parameterized constructor, while creating the object, you have to pass the value for that parameters. That is, we have to pass the argument. So again, the question is how to pass the argument. I have two different ways for doing that. One is I can do it like this, dynamically. Other one, statically, of course. Right, so now I can say, so I'm taking a dynamic input, then I am passing this value yes here. This is one way of creating the object. So creating object by passing the value of yes as parameter. We're going to pass this yes value as a parameter. Done. My first step is done. Now, how to do it the second time? You can give direct values also. I can give direct values. That is, inside this, I can directly say, okay, this is the value. This is the name. This is the name. So what is going to happen? When you're getting dynamically, I'm storing the value here and that value I am passing. So whatever is the value of yes will go and get stored in NA, and that NA is internally assigned to my name. That is one way of doing it. Otherwise, directly you can say like this. So this Anusha is going to go and get stored inside NA, and that is going to get assigned to this variable name. Now, when I run this, see what happens. So first time it's asking me enter the name, that is for my dynamic input. I am giving the name here and see what happens. So this is an example of a parameterized constructor, a constructor having some parameters. How many parameters? What is the data type? Everything is your choice. Again, according to the given question for the program, you have to decide, okay, whether I should go for a parameterized constructor or a non-parameterized constructor. So what are the parameters I have to pass? So everything is decided based on the given program. Based on what they are asking you to do, you are going to be deciding all the factors. Right. So this is the base idea about our constructors. Right. So generally, let us recap. So what is a constructor? A constructor is nothing but a special method that is used to initialize my instance variable. So this is an instance variable. So I want to give a value for this variable. But I don't want to first create an object and then give the value. I want the work to happen simultaneously. So I am going to take the help of my constructor. So here, see what happens. When you're creating the object itself, you're passing the value for the instance variable. You can have how many ever instance variable you want. Let us say I have another one. I have something like this, roll number. So here, I'm going to add another parameter, int RNO. So I'm going to say roll number is equal to RNO. Like this, how many ever variables are there? You can keep adding the parameters. But remember, Here, if the constructor is having two parameters, here also it should have two parameters. Okay, here also you should give two parameters. You should create the values like that. Okay, so here also I have to give, okay, come on, some some roll number. Here also some roll number must be given. So you can either take the value dynamically from the user, or you can give the value. That is your choice. See, I need to print it. I have not printed it. Printed, you will definitely get that value also. Now when I run, see what happened. Name, roll number, name, roll number. So how many ever parameters you want, that is entirely your choice. Whatever you feel like giving, you can give it here. So here I'm just making it dynamic. Since we had it as dynamic, I'm just going to keep this also equally. Right, now it is no longer only name. You have different things. So I'm just going to call this function as display info. There you go. Run it. So first value and then the second value, both are working perfectly for us. Right. So this is how I will be making use of my constructors. Right. I hope these examples are clear for you.